Hello and welcome to our second video in methods for level 2s. Your job here is to work with SOHCAHTOA, so the sine, cosine, and tangent laws of a right triangle. We're going to create a console app that can solve for an angle when you get two of the three sides. So you're solving for an angle, two of the three sides, but we're only going to give you different sides. The first part of the question is making three different methods. One for sine equals opposite over hypotenuse. One for cos, which is cosine equals adjacent over hypotenuse. And then for tangent, which is tangent is equal to opposite over adjacent. I want you to solve those three all in separate methods, and you'll just call those three methods from your main method. We're not going to worry about this second part right now. You're just going to start off. It's kind of, again, working from the inside out, creating three different methods that we'll solve. Now, a couple things you need to know about this. And I've got some information down here. It says we use the inverse sign. So to do that, you have to do the inverse sign. And in the math class, it's a sine. So inverse cos is a cos, and inverse tan is that. Now, on your calculator in math class, you're able to change it from radians to degrees. So this works in radians in the math class. So what you have to do is you convert the degrees by multiplying by 180 and dividing by pi. And pi you can also get from the math class. Give that a try. Think about it. You may work with a partner, but you each have to do your own. Feel free to talk about it and try and solve that. I've got three examples. So one of the first ways to start is check against this one, right? So I've got angle A, and that is the opposite. That's the hypotenuse. So this would be using the sine law. And the angle, when you figure it out, is 36.87. Try it for this one, for the sine law. And if you can get that, you'll be on the right track. You should be able to do it for the cos law and the tangent law as well. So pause the video and give it at least half an hour trying to do this on your own. If you're really getting stuck, then come back and check out my solution. But at least half an hour for level 2s that you should be trying to do this on your own, researching things on the internet, finding out how to do it. All right, welcome back, and I hit start. So my output is this, the sine law. Using the sine law, triangle with the opposite of 20 and a hypotenuse 29, the angle is this. Cosine, using the, I should have said cosine law there and tangent law here. A triangle with the adjacent of 40 and hypotenuse of 41, the angle is pretty small. It's 12.68 degrees. And in the tangent, when we have an opposite of 5 and an adjacent of 12, the angle B is 67.38. So how did I do that? The first thing is you got to start down here by making outside of your main method. This stuff is all easy for you. Outside of your main method, we're going to call it public static double SO for SOHCAHTOA. And I'm going to input because sine law is opposite over hypotenuse. That's why I named it SO. And it's going to intake the double opposite and the double hypotenuse. So then double sine angle, so I gave it called it a variable, is equal to math.asine, which is inverse sine, two parameters taken in, both of them are doubles, opposite over hypotenuse, times 180 and divided by pi. And you can get pi as math.pi. But because we have a return type, it's very important that you return the sine angle. Then I did exactly the same for cos, except cos is adjacent over hypotenuse. And then for tangent, which is opposite over adjacent. And again, the inverse tan is a tan and the inverse cos is a cos. Then I went to the main method and I just put in those numbers of those triangles that we're checking. We're going to get the user to put those in the next one. Right now, I just made a variable again, and it's in a different method. So you had to first instantiate it as sine angle, and then sine angle is equal to the method. And then I just write out this thing with curly bracket 0. Curly bracket is referencing sine angle. So it prints it out for us. And that is how you do step 1 of this problem. Thanks for watching.